Find the exact values of the trigonometric functions for the acute angle theta. Make note that that's an acute angle, where secant of theta is equal to 6/5. Well, first we can use the reciprocal identity for secant theta to note that cosine of theta, which is always the reciprocal of the secant of theta, at least for values of theta for which both are defined, is going to tell us that cosine of theta is 1 divided by the secant. That's 1 divided by 6/5, or just 5/6. So we've got the cosine of the angle nailed. It's equal to 5/6. Now we also know that cosine is the ratio of the adjacent side of a right triangle to the hypotenuse of a right triangle. Let's sketch a picture of that here. If we have a right angle and an angle theta, that's an acute angle, then the adjacent side over the hypotenuse will have proportion 5 to 6 if we have a cosine that's equal to 5/6. Well, given that, we can find the value of the opposite side by using the Pythagorean theorem, which says that the sum of the squares of the legs will equal the square of the hypotenuse. So we have 5 squared plus the opposite side squared equals 6 squared. And again, we want to make sure that we have the two legs here and the hypotenuse on the right-hand side of the equation. Solving for this gives me that 25 plus the opposite side squared will equal 36. Subtracting 36 tells me that the opposite side squared, or rather subtracting 25, tells me the opposite side squared must equal 36 minus 25, or 11. So the opposite side is the square root of 11 units long. That allows me to complete the rest of the trigonometric functions. The sine of theta is equal to the opposite over the hypotenuse. That's the square root of 11 over 6. While I'm doing sine, I'll also do cosecant of theta, because cosecant is the reciprocal of the sine of theta. That will be 6 over the square root of 11. I should rationalize that denominator by multiplying the top and bottom by that irrational denominator. Doing so gives me 6 square root of 11, and the square root of 11 times itself is just 11. So the sine is 11/6. The cosecant is 6 square root of 11 over 11, if I've written that in its simplified form, this rationalized form. So we've got 1, 2, 3 down. Let's do the tangent next. Tangent of theta is opposite over adjacent. That will give us the square root of 11 divided by 5. And finally, the cotangent of theta is the reciprocal of the tangent of theta, which is 1 over 11, square root of 11/5. That will be 5 over square root of 11, and like I did up above, I'll rationalize that denominator since I have a square root in the denominator. That's 5 root 11 divided by 11. So there are my 5 trig functions in addition to the one that was given before.